The broadcast is now starting. All attendees are in listen-only mode.
Hello everyone. So as I said, I'm going to take it 5-6 videos based on geometry in XAT previous year questions. So this is the second session of XAT. In this session, I'm going to discuss the geometry questions, and there are two sessions as there are many questions based on geometry. So in this session, I'm covering 2013 to 2015 questions, and then I'll cover 2016 to 2018 in the next session. Okay. So let's start with 2013 geometry questions. As I said earlier also, first try to do it your own. If you're not able to solve it by your own, then only look for the solution. So this is the first question, 2013. The question says, as the center of a city municipal park, there is a large circular pool. A fish is released in the water at the edge of the pool. The fish swims north for 300 feet before it hits the edge of the pool. So if you can see in the solution, let's say there is a large pool. At this edge, the fish is released and it swims for 300 meter before it hits the pool. Then it says it then turn east. Now if it is going that side, east will be that side. It turns that side and swims for 400 feet before it hits the edge of the pool. So it hits 400 meter again. So now you can see this is 300 meter and this is 400 meter, and if I join this line, this is a straight line and this is a 90-degree triangle. This is a 90-degree triangle. So can I say 300, 400? So this AC will be 500. And this AC is making a 90-degree angle at the circumference of this circle. So if this AC is making a 90-degree angle at the circumference, so AC has to be diameter, because diameter makes an angle of 90 degree at the circumference. So if AC is diameter, so AC is basically 500. So diameter it's 500. So radius will be 250. If radius is 250, what is asking? It is asking, now this information it's not relevant because we need not to use it. It further turned 400 somewhere here. We need not to use it. What is the area of the pool? So area is a circular pool. So area of the pool is pi r square. Here r is 250 meter. So what is the area? Area is pi r square, that is 250 square, which is 62500 pi. And that is the answer. That is the first option, which is the answer. So simple question, you need to just draw it. It swims 300 meter and then runs towards east direction and swims 400 meter before it touches the pool. So join it. This is the 90 degrees, so 300, 400. So this, with the help of Pythagoras or 3-4-5 ratio, you can say it is 500. This becomes diameter. So radius will be 250 and area will be 62500. Okay, come to the next one. Now second question says, the central city park of the city is 440 meter wide, 40 meter long and 30 meter wide. So let's say this is 40 meter and this is 30 meter. So total area is 1200 meter. The mayor wants to construct two roads of equal width. So two roads of equal width. Let's say this is one road and this is the second road. The width is d meter, let's say. They intersect each other at right angles, and the diagonal of the small rectangle formed at the intersection of the two roads. Right? That is a diagonal. That diagonal is the same diagonal. Further, the mayor wants that the area of the two roads, this road and this road, to be equal to the remaining area of the park. Now that is the question. What is the remaining area? Remaining area is this. That area of this road and this road is equal to the remaining area of the pool. So basically, the red part is equal to the black area. So can you see this is D and this is 30? So what is the area of this road? That is a rectangle. D into 30, that is the area of one road, that is 30D. And what is the area of this road? That is D, but that is 40. So area of this road is 40D. So area 1 I'm naming it, and area 2 it's 40D. So can I say it is 70D? No, I cannot say 70D because I have counted this area twice. What is that area? That is D and that is also D. So this D square has been counted twice. So we need to subtract that D square also. So that is the complete area of the road. That is the road area. That is 70D minus D square. And what is the complete area, guys? The complete area is 1200. So if this area is equal to the remaining area, so can I say if this area is X, this area is also X? So X plus X becomes 2X and complete area is 1200. So can I say this area and the remaining area is equal? So this area has to be 600 meter. Are you with me? Because this area is just half of the is equal to this area, so it is half of the total area. Total area is 1200, so half of the area is 600. So what do we get from here? We get d square minus 70d plus 600 equal to 0, and from here we get two values of d, that is d minus 60 and d minus 10. Obviously d cannot be 60, so d has to be 10 meter. That is the answer. The question is, what is the width of the road? Width of the road is 10 meter. Simple. So put it equal to half of the area, which is 600. Come to the next one. Now this is again a simple question. In a square PQRS, this is the square PQRS. A and B are 2 points on PS and SR, so that PA is equal to twice of AS. So that PA is equal to twice of AS. This ratio is 1:2. And RB is equal to twice of 2BS. RB is equal to twice of BS. So this ratio is also 1:2. PQ is 6. PQ is 6, so all the sides are 6. This is also 6. This is also 6. So this is 1:2. So I can say SB is 2 and BR is 4. This is 2 and this is 4. The area of the triangle ABQ. We need to find the area of this triangle, that is ABQ. We need to find the area of this triangle. So rather finding the area of this triangle, what I can do, I can subtract the remaining area from the total area. What is the total area? The total area is 36. It is square of side 6. What is the area of this triangle? Triangle PQA. The area of triangle PQA is nothing, it is half base into height, which is 6 into 4, 12. Similarly, what is the area of QBR? The QBR is also same, half 6 into 4, 12. And what is the area of triangle ASB? The area of triangle ASB is nothing, it is half 2 into 2. It's again a triangle, so 2. So if I subtract this area from the total area, I'll get the area of this triangle, which is the required answer, that is the area of QBA. What is the area? If I subtract 26, I'll get the area, which is 10. It's a very simple question, I think, as far as Z is concerned. And do not consider Z as a different difficult exam, guys. You will get around 10 to 12 questions, which is very easily to it. And geometry, I have seen, I think, all the questions from 2013 to 2018 and previous also. They're not much difficult than CAT, right? So if you have done geometry in CAT, it is more than enough. Come to the next one. Yeah, that was a difficult. Out of all the four questions, that was a difficult question. The radius of a circle with center OH 50 root 50 centimeter. A and B are A and C are the 2 points on the circle, and B is inside the circle. So let's say there's a circle. A and C are the 2 points on the circle, and B is inside the circle. The length of AB is 6. So let's say this is AB. A and C are the 2 points. This is 6, this is 2. And the length of AB, the angle ABC is a right angle triangle. So if this is 6, this is 2, I can say this is root 40, 36 plus 4, 2 root 10. The first step, I get the length of AC, which is 2 root 10 by Pythagoras. The angle ABC, find the square of the distance OB, and O is the center. We need to find out this basically. OB, the square of OB. So what I do, I drop a perpendicular from here. Let's say I name them OD, that point is D, that is D. So this is D, and you know that if I drop a perpendicular from the center on a chord, it bisects the chord. So CD is root 10 and AD is also root 10. CD and AD both are root 10. Now till here I'm sure it is clear. Now what I can do, if I drop a perpendicular from a right angle triangle, the length of that perpendicular, let's say BE, what is the length of BE? If you have done geometry in CAT, then you know that length of BE is 2 into 6 upon CA. Or you can equate the area. Area of this triangle is half base into height. Or I do it normally for you. Half base I'm taking AC, which is root 40 or 2 root 10. And height we need to find, that is BE. And if I take base and height like this, so this is base and this is height, or vice versa. This is base, this is height. So area of the triangle I can equate from both the sides. So from here you will get the value of BE. That B is nothing, it is, the 2 will also be cancelled out, 6 upon root 10. This is BE. The BE is 6 upon root 10. If BE is 6 upon root 10, similarly, if I drop a perpendicular from here, can I say DF is also 6 upon root 10? This becomes a right rectangle now. BEDF, it becomes a rectangle. So BE is 6 root 10. So DF is also 6 root 10. And do we know the length of OD? OD, we can get it, guys, very easily. The radius is given root 50. If radius OA is given root 50, and this is 2 root 10, so what is the length of OD? OD is nothing, it is, this is square minus this is square. So 50 minus, that is root 10, AD is root 10, so 10, it is root 40. But also comes out to be 2 root 10. OD is 2 root 10. So if OD is 2 root 10 and DF is 6 upon root 10, so can you tell me the value of OF? We get the value of OF. OF comes out to be, if I subtract 2 root 10 minus 6 upon root 10, I'll get the value of OF, that is the length, OF. The complete length we know, OD we know, DF we know. So if I subtract OD minus DF, I'll get the length of OF. So that is 10, 20, 20 minus 6 is 14 upon root 10. That is OF. So you get OF, we need to find OB. So what is the length of this BF, guys? Okay, we do one more step. We have the length of BE, that is BE. So if we have the length of BE, so as I said, we need to do 3-4 steps in this question. We have the length of BE, we have the length of BC, that is 2. So can I get the length of CE? C is nothing, it is this square minus this square. That DF we already got now. DF is 6 upon root 10. So DF is 6 upon root 10. So BE is also 6 upon root 10. So 6 upon root 10, and that is 2. So can I get the length of CE? CE is A square minus B square, that is 36 upon 10. So that is root 4 upon 10, or I can say 2 upon root 10. So now I have the length of CE also. So what is ED? ED, that is root 10, and that is 2 upon root 10. So root 10 minus 2 upon root 10, that is 10 minus 2, it is 8 upon root 10. So that is the length of ED. and ED is equal to BF. So now you have the length of BF, you have the length of OF. So now you can find the length of OB. So 3-4 steps you need to do. So this is square plus this is square and that root of that. And basically we need to find the square. So you need to find the root. Directly find it. 64 upon 10 plus 196 upon 10. So that comes out to be 260 upon 10. That is 26. So OB square is nothing, it is 26. So that is a difficult question. Obviously, I'm not saying it is easy. So that is a difficult question. But now I'm sure this is clear. We drop a perpendicular. We get the length of CD and DA, that is half of that. Then we get the length of OD, then OF, and then BF. So when we find the length of BF and OF, we can find the length of OB. Okay, so out of 4 questions, if one is difficult, obviously you can leave it, but 3 were doable in the exam hall. Come to 2014 exam. That was again easy question. Basic property of triangle if you can apply. The question says in a quadrilateral PQRS, you can draw any quadrilateral, general quadrilateral. I'm naming them randomly. A quadrilateral PQRS, PQ it's 5, QR is 17, RS it's 5 again, and PS is 9. So as I said, I have drawn it randomly. You need not to be bothered about whether it is looking lengthy or it is looking short. No need to be bothered about. The length of the QS. The length of the QS can be. Now in this question, only the basic property of triangle we can use. If you see this triangle PQS, if you see the triangle PQS, the sum of two sides QS has to be less than the sum and greater than the difference. If you know the basic property of triangle, in this triangle, the length of the third side QS is less than the sum and greater than the difference. So QS has to be less than 14 and greater than 4, right? And similarly, if I look at the triangle QSR, according to this, the length of QS is less than the sum, which is 17 plus 5, and greater than the difference, which is 17 minus 5. So the length of QS will lie in the range of 22 to 12. So can you tell me the basic range of QS? QS from here you are getting 4 to 14, in between 4 to 14, and from here you are getting 22 to 12. So what is the common range of QS? The common range of QS is obviously, if I put it on the number line, that is 12 to 14. It is saying 22 to 12. It is saying 14 to 4. So what is the common range which is satisfying both the condition? That is 12 to 14. And that is the answer. The length of the diagonal QS will be in between 12 to 14. That is the answer B. So in this question, only the basic property of triangle was used. So good question. Okay, come to the next one. Now this kind of question, I think appearing one or two statement will be given and you have to find out that which statement is sufficient to answer the question, right? So triangle ABC is right angle triangle. D and E are the midpoints of AB and BC respectively. Read the following statement. Now in this question, basically the tricky part is that you do not know which angle is a right angle triangle. So I cannot directly draw it ABC is a right angle triangle by taking B as a 90 degree. It can be any point which can be 90. So we do not know. D and E are the midpoints of AB and BC respectively. If I draw it like this, D and E are the midpoints. Right? I draw, let's say, all three combination. The right angle can be B, right angle can be A, right angle can be C. I draw it all three combination. And then we'll see which is sufficient to answer the question. These are three possibility. No other possibility exists. So this point can be C, this point can be A, this point can be B. Now if I'm taking AB, so this is angle, this is side D and this is E. Here this is D and this is E. D and E are the midpoints of AB and BC respectively. A is 19. In this question, this is given 19. If I join this, here it is given 19, and here this is given 19. CD is 22, CD is 22, CD is 22, CD is 22, and CD is 22. Angle B is right angle triangle. So if we do not know this information, angle B is right angle triangle, which of the following statement would be sufficient to determine the length of AC? Now, can you get the length of AC in this case? AC. Here, if this is X, this is X, this is Y, this is Y. Obviously, I have one information, X square plus 2Y square equal to 19 square. And the second information I have, Y square plus 2X square is 22 square. By solving this, we can get the value of X and Y, and once we get the value of X and Y, we can get the answer. But we are getting the answer if we know that this is a right angle triangle. If we do not know this is a right angle triangle, just check, can we get the length of AC? Now, can we get the length of AC here? This is X, this is X, this is Y, this is Y, and this will also be Y, right? But this time, can you get the length of AC? Only information, AC square plus X square is 22 square, and there is no relation as such. So, statement 1 and 2 alone are not sufficient to get the answer until and unless I do not club it with third equation or third information. I cannot get the exact answer of AC. So here, if you want to go through the solution as well, here I have written the solution as well. But it was obvious from the picture that unless we do not have all the three information, we cannot get the exact length of AC, right? So all the three information are required. So correct answer is option 5. You can go through the solution also if you want to go through the theory part. Otherwise, with the picture, with the figure, it is obvious that we need the angle. We need all three information to get the answer. Okay, come to the next one. Again, this is a good question. I've drawn the figure also. There are two circles, C1 and C2, of radius 3 and radius 8 centimeter. The common integral tangent, this is a common integral tangent, T touches the circle at points P1 and P2. That is a common tangent. The line joining the center of the circle intersect T, this is a T, at X. The distance of X from the center of the smaller circle is 5. What is the length of the segment P1 and P2? We need to find out this length. So this is the radius 3, this is 5. So obviously we can get the value of Px, that P1x is nothing but 4. First step. Now P2 we know it is a radius 8. Do we know this angle and this angle are equal? Vertical opposite angle. This angle is 90 and this angle is 90. So can I say triangle AXP1 is similar to triangle? Now in front of X I'll write X. In front of P1 I will write P2, as both of them are equal. So the third angle B also has to be equal to angle A. So these two triangles are similar. So now we can use the proportional theorem. AX upon BX is equal to AP1 upon BP2 is equal to XP1 upon XP2. So from here we have the length of AX, which is 5. We have the length of BX. No, we do not have the length of BX. AP1 is given as 3. BP2 we have 8. XP1 it's 4, and XP2 we do not. So what do we get? We need to basically find the value of XP2 only. So I'll use these two to get the value of XP2. The length of XP2, it's nothing, it is 32 upon 3, that is 10.66. So XP2 is 10.66 and that is 4. So what is the length of P1, P2? The length of P1 and P2 is coming out to be 14.66 centimeters. So what is the answer? Answer will lie in the range of 14 and 15. The correct answer is 14.66, which is in the range of 14 to 15. So use the similar triangle to get the answer. This was doable question in the example. Come to the next one. This is also doable. The question was there are two squares S1 and S2 with areas 8 and 9. So obviously the small area will be S1 and there's a bigger area that is S2. Area is given, so side is given. The complete side of S2 will be 3 and complete side of S2 will be 2 root 2, root 8. Root 8 is 2 root 2. S1 is inscribed within S2 with one corner of S1 on each side of S2. One corner of S1 with each side of S2. The corner of the small square divides the side of the bigger square in two segments. One of the length is A. So let's say this is length A and this is B, which is 3 minus A. So complete side is 3. This is A, so this is 3 minus A. Where B is greater than a possible value of B by A is. We need to find out the value of B by A is. So you can apply the Pythagoras theorem in this triangle. That is A because it will be in symmetry. So this is A, this is 3 minus A and this is 2 root 2. So I can say that 2 root 2 whole square that is equivalent to a square plus 3 minus a whole square. So you will get a square plus 9 plus a square minus 6a, that is 8, and 2a square minus 6a plus 1 is equal to 0. So basically no root as such. So I'll use the formula to get the answer. The value of a comes out to be minus b plus minus b square minus 4ac upon 2a. So the answer comes out to be 6 plus minus root 28 upon 4. I can cancel out 2, which is 3 plus minus root 7 upon 2. Obviously it cannot be negative. No, it cannot be, a cannot be, there are two values, 3 plus root 7 upon 2. If I take 3 plus root 7, so that will be 2 point something and the value will be more than b, because if a plus b together it's 3 and b is greater than a, so obviously a has to be less than 1.5, a has to be less than the half. But if I take 3 plus root 7, a will be more than the half, so it is not possible. So the only possible value for a is 3 minus root 7 upon 2. So that is a. What we need to find out, we need to find out the ratio of b by a. So what is b? B comes out to be 3 minus root 7 upon 2. That is 6 minus 3, 3 plus root 7 upon 2. So either you can put it the value of root 7 here, or you can rationalize it. That is the ratio. So if I multiply with 3 plus root 7, I'll get the range, that is a plus b whole square. So 9 plus 7 plus 6 root 7 upon 9 minus 7, that is 2. So 16 plus 6 root 7, that 8 plus 3 root 7 is the answer. So root 7 will be 2.69. That is root 7 will be around 2.5 is 6.25. So 2.6 is 6.67. 2.7 will be 7.29. So around 2.65 for the safer side, let's say. So that is 6, 7.8, 15. So the range is in between 14 to 17. Okay. So you can put it the value also. It will be comparatively easier to calculate. I rationalize it. We could have used the value here itself. One of the same thing. But main thing is to reach here and to ignore this value because it is not possible. Okay. Come to the next one. Come to the next Z 2015. So in this session, I'm going to take till Z 2015. In the next one, I'll take 2016. Look at this. A solid metal cylinder of 10 centimeter height and 14 centimeter diameter is melted and recast into two cones in the proportion 3 to 4 volume, keeping the height 10 centimeter. What will the percentage of flat surface area before and after? Now, if we talk about the cylinder, the flat surface area, we are talking about this area, this area, this area. We are not talking about the curved surface area. We are not talking about the total surface area. We are talking about this flat surface area, which is pi r square plus pi r square. That's 2 pi r square. So if we know the earlier radius was 7, so that is the earlier flat surface area. That is 98 pi. That is the earlier flat surface area. And what is the volume? The volume was pi r square h. That is 490 pi. And that 490 pi has been divided in the two cones in the ratio of 3 to 4. So if I divide it in the ratio of 3 to 4, the two volumes are 210 pi and 280 pi. Keeping the height same, so height is 10. So we get the radius of two cones, that is the one volume. So R1 square comes out to be 63. I'm putting it R1 square, I'm not taking it the root because we need actually R square only. And the second volume is 280 pi. So 1/3 of pi R square h, it's 280 pi. The pi is cancelled. 10, 28 is cancelled. So R2 square comes out to be 84. This is the radius of the two cones. So what is the flat surface area of these two cones? That is again pi r square. That is the flat surface area. That is pi r square and that is also pi r square. The radius of this cone is 63 and the radius of the second cone is 84. That is 84. So what is this flat surface area? It's pi r square is 63 and this it's 84. So total area comes out to be 147 pi. Earlier it was 98 pi, now it becomes 147 pi. So what is the change? It has been increased by 49 pi over 98 pi into 100. So the percentage change is nothing, it is half, that is 50%. And that is half. So flat surface area, you need to remember that is the area of the base only. So 98 pi earlier, now it becomes 147 pi. So as you can see, there are certain question which is based on mensuration as well, which has appeared in set. So not only geometry, but also mensuration is also important as far as Z is concerned. So go through the basic concepts of mensurations. Come to the next one. There is also mensuration. Circular road is constructed outside a square field. That is a square field, and there is a circular road constructed. That is a road outside this field. The perimeter of the square field is 200 feet. So perimeter is 200. So the side is 50. If the width of the road is 7 root 2 feet, so the width of the road is 7 root 2. So if the side is 50, can I say the diagonal will be 50 root 2? That is 50 root 2 and that is 7 root 2 and 7 root 2 both the sides. And the cost of the construction is 100 per square feet. Find the lowest possible cost to construct 50% of the total load. Now, lowest possible, it's basically of no use. We need to find the cost to construct 50% of the total load. So can I take it as a bigger circle, and if I subtract the area of this inner circle, I'll get the area of this part. So what is the diameter of the bigger circle? The diameter of the bigger circle is nothing. It is 7 root 2 plus 50 root 2 plus 7 root 2, that is 64 root. So what is the radius? The radius is 32 root 2. And the diameter of the smaller circle is 50 root 2. So it is 50 root 2 of the smaller circle. The radius will be 25 root. So if I subtract this area of the bigger circle, which is 32 root 2 square pi, which is 1024 into 2, it's 2048 pi. And the area here I'll get it's 25 root 2, which is 625 into 2, 1250 pi. So that is the area of the road. The area of the road comes out to be 750 plus 49, that is 798 pi. And the answer is not given in terms of pi, so I'll multiply with 22 by 7. And the road is 100 square per feet, so I'll multiply with 100. But we need to find the cost of only 50% of the road, so we need to make it half also. So if you simplify it, that is 114. 114 into 22 comes out to be, or 114 into 11, you can do it directly. That is 452100. 125400 is the total cost, and that is the answer. So simple question, we need to find the cost of the road. So find the area of the bigger circle, subtract the area of the smaller circle to get the area of this part. This is also mensuration. Simple. Come to the next one. This was again a good question. 30, 60, 90 triangle based question. In the diagram below, CD is equivalent to BF. CD, should I draw it bigger figure? Okay. Okay. So this is a question that is AFB, that is a C, D, E, CD, it's 10, CED, CED is equivalent to BAF, so that is given 30, that is also given 30. What would be the area of the triangle AED? We need to find out the area of AED, this triangle, and that angle is given 90, and that is also 90. So this is 90, this is 30, so this is 60. This is 90, this is 30, so this is 60. So basically this question is nothing, it is a 30, 60, 90 triangle question. And if I'm sure if you've done geometry, then you know that the ratio in front of these side is 1 is to root 3 is to 2, right? So in front of 30 we know the side is 10, so 1 denotes 10, so root 3 will denote 10 root 3, and 2 will denote 20. So this side it's 20, this is 10 root 3. Similarly here we know BF it's 10, so again 1 denotes 10, so root 3, that AB will be 10 root 3 and AF will be 20. So that is 20, that is 10 root 3, that is 10. What we need to find? We need to find the area of this triangle. So here again look at this triangle also, that is the remaining triangle. This is 60, so can I say this angle will also be 60, vertical opposite angle. This is 90 and this angle is 30. So once again you need to find out in triangle BCF, because this length is remaining. If I get this length, I have this length, I can get the area of the bigger triangle. So look at the triangle BCF. Again, it is a 30, 60, 90 triangle. So the side in front of 60 is given 10 this time. So root 3 basically denotes 10. And we need to find out this length, that is 1. So 1 will be 10 upon root 3. So root 3 is 10. So 1 will be 10 upon root 3. So that BC length is 10 upon root 3. So can you tell me the total length? That is 10 root 3, that is 10, and that is 10 upon root 3. BC is 10 upon root 3. So what is the length of AD? The length of AD, it's nothing, it is 10 root 3 plus 10 upon root 3 plus 10. So all the three kind of figures. So that is 30, 30 plus 10, 40, 40 plus 10 root 3 upon root 3 is the length of AD. And we have the length of ED, which is 10 root 3. So what is the area? Area is nothing, it is half base into height. The height is 40 plus 10 root 3 upon root 3. That root 3 will cancel out, that is 5. So what is the area? Area is 200 plus 50 root 3. So what would be the area of triangle AED? That is 200 plus 50 root 3. That is 300 plus 100 root 2. So 200 plus 50 root 3, that is the option D. Option D is safe. Look at closely. That is 50 into root 3, that is 50 root 3 plus 200. That is the answer. So 30, 60, 90, apply it and do it quickly. So that is, if you've done geometry earlier in my classes, and if you know the basic concepts, I'm sure you can do this question very quickly. Okay, come to the next one. This is a good question again. The parallel sides with trapezoid ABCD are in the ratio 4 is to 5. That side and that side is in the ratio 4 is to 5. So that complete side is 5. ABCD is divided into isosceles triangle APB and parallelogram PBCD. So this side is 4x, so this is also 4x. ABCD has a perimeter equal to 1120. So this side is y, so this side is also y. This is x. So obviously, if it is an isosceles triangle, the two sides can be equal to xx also. The two sides can be equal to yy also. What is given? ABP, ABP, and a parallelogram PBCD. These two angles are equal. ABCD has a perimeter equal to 1120 meters. ABCD has a perimeter 11 to 1120, and PBCD has given a perimeter of 1000. Given that twice of angle DAB is equal to BCD. So if this angle is theta, or I should say this angle is theta, ABD, DAB, this angle is theta, so this angle is 2 theta. So if this is 2 theta, this is also 2 theta. Now if this is 2 theta, this angle also has to be theta, exterior angle. This is theta, this is 2 theta, so this has to be theta. Theta plus theta will make it 2 theta, exterior angle property. It means these two sides are equal. The angles are equal, so side in front of this and side in front of this is equal. That is 180 minus 2 theta. So from here, x is coming out to be equal to y. This is equal and this is also equal. So this is also x. Yeah, these two sides are equal. From here, we are getting x is equal to y. So I can replace this y with x. This is also x, this is also x. These two sides are equal. So what is the perimeter now? The perimeter is given as 4x plus x, 4x plus x plus 4x plus x, parallelogram, that is 8x plus 2x, that is 10x, that is given as 1000. So x comes out to be 100. If x is 100, if I add these three sides, that will be 400, that will be 100, and that will be 500. So that remaining side, that is 400, 500, 1000, so that AB comes out to be 120. AB comes out to be 120, and these two sides comes out to be 100 and 100. What do we need to find out? We need to find out angle ABC. That we need to find out. This is angle is 180 minus 2 theta, because sum of the two adjacent angle is 180. So this is 2 theta. So this will be 180 minus 2 theta. We need to find out this angle, sine angle ABC. That is nothing, it is sine 180 minus theta. 180 minus 2 theta plus theta, sine 180 minus theta. Sine 180 minus theta is nothing, it is sine theta. So basically we need to find the value of sine theta. And I'm sure you are aware that sine rule, sine theta upon x, which is 100, is equivalent to sine 180 minus 2 theta upon 120. Sine rule. So there is 5, there is 6. So sine theta upon 5. Sine 180 minus 2 theta is sine 2 theta, and sine 2 theta is 2 sine theta cos theta. That sine theta will be cancelled, and that is 3. So cos theta comes out to be 3 by 5. If cos theta is 3 by 5, what is sine theta? Sine theta is nothing, it is 4 by 5. So what is the value of sine theta? Sine theta value is 4 by 5. That is the answer. Very good question. Using trigonometry also thoda sa. Otherwise, sine rule we basically used in geometry itself. But yes, sine 180 minus theta, you should know it is equal to sine theta. That we are using it with the help of trigonometry. Done? Good question. Look at it. The center of the circle inside a triangle is at a distance of 625 centimeter from each of the vertices of the triangle. If the diameter of the circle is 350 centimeter and the circle is touching only two sides of the triangle, find the area of the triangle. This is again a good question, guys. A difficult question. Look at it. The question is something like that. The triangle, the circle is touching only at two sides, and the center is equidistant from all the three sides, all the three vertices. That is the question. The inside of the circle is at a distance of 625 centimeter, and if I extend it, that will be 90 degree. That's the radius. So if diameter is 350, the radius will be 175. I name it, let's say, ABC. So this is 175, this is 625, this is a right angle triangle. If you again compare the ratio, this is 25 into 25, this is 25 into 7, and this is a right angle triangle. So this is 25 into 25, this is 7. So if you are aware, the Pythagoras triplet, that is 7, 24, 25, or you can use normal Pythagoras. So from here, 7, that is 25 into 7, that is 25 into 25. So the third side will be 25 into 24. 7, 24, 25 are the triplet. That is 600. So again, if I name this point as D, and if I extend this also, that will be again a straight line. The circle is touching here. That is the distance. Let's name this point as E. So this AD comes out to be 600. Normal Pythagoras, again you can use it if you do not know this rule. 7, 24, 25 here. 7, it's 175, that is 625, so this will be 600. AD comes out to be 600. Similarly, AE will be 600, the other tangent, that is 600, so that is also 600. There is again 90 degree angle, the radius is 175. Similarly, that BE will also be equal to 600. Similarly, 175, that is 625, so this will also be 600. That will also be 600. CD will also be 600. AD and AE is also 600. So basically this becomes an isosceles triangle. AB and AC both are equal to 1200. And if you know, if you drop a perpendicular that will bisect the base, this will be a perpendicular, the passing through the center, and this is bisecting the base. Now what we need to find out? There is the diameter is given, circle is touching, find the area of the triangle. We need to find the area of the triangle. Now one more thing we can use it here. Just give me a second and you just think what I have done it earlier. Now can I use it, this small triangle and this bigger triangle are similar triangle? Can I say triangle, let's say I name them this point as F, triangle AFC is similar to triangle in this AFC and this ADP, that angle A is common, AFC and ADP, that D is 90 and AF 90. So as soon as I get two angle equal, the triangle will be similar, ADO let's say. So now I can find the value of AF and FC also. AF we do not know. AD it's 600. AC it's we know it's 1200. AO we know it's 625. FC FC we do not know. DO we know. DO it's 175. So we can get the value of AF and FC both. If I use these two, I'll get the value of AF. If I cancel out with 25, that is 25 into 24, 25 into 50, 25 into 48, that is 1200 into 600 upon 625. Cancel out with 25, that is 24, that is 48. So that comes out to be 48 into 24, which is 576 into 2, which is 1152. Similarly, if I get the value of FC, FC comes out to be 1200 into 175 upon 625. That is 25, that is 7, and that is 48. So that comes out to be 48 into 7, which is again 280 plus 56, 336. FC we know, AF we know. What is the area? Area of the triangle is half base into height. Half base will be double of that, 664, into height. Height is AF, which is 1152. So that is, sorry, 672. So 336 into 1152 is the answer. And options are given none of these as well. But if I go with the unit digit, I'll go with this answer. Answer is 387072. But still, you can multiply and check yourself. Right now, I'm not multiplying it. I'm just marking it. Otherwise, you can check with the digit sum also if you know the digit sum rule. The digit sum rule says add the digits of this number, which is 12, which is 3. Add the digit of this number, which is 7 plus 2, 9. That is 27, and that is 9. So the digit sum of the answer should be 9. If the digit sum of the answer is 9, answer can be true. So that is 9, 9 plus 7 is 16, 16 plus 7 is 27, 27 is again 9. So I'll mark it with a estimated guess, that is 387072 is the answer. But still, it is better to check. Okay, bye bye. I think one more question is left. Yes, one more question is left. There is difficult, seems to be difficult. It is not actually. The figure below has been obtained by folding a rectangle. That is a rectangle, complete rectangle. We have folded it. The total area of the figure is 144 square centimeter meter. Had the rectangle not been folded, the current overlapping part would have been a square. So check it here. If this not had been folded, this overlapping part would have been a square like this. What would have been the total area of the original unfolded rectangle? We need to find out the area of AGHD basically. So that is given 6, that is given 14 till here. If this is 6, this is also 6, this is also 6. There is a square, so this is also 6, this is also 6. So the area of this part, it's given 144, right? What is the extra area we need to add? If I put it like this, what is the extra area we need to add it? That area has been added in this 144. This area has been added in this 144. This area has been added in this 144, but this area has not been added in this 144. So to find the complete area, we need to just add this area as well. So what is that area? Area is nothing, it is 6 into 6 ka half of the triangle. So we need to add 18 in this area to get the complete area. So the correct answer is 162 meters square. So as I said, this seems difficult. It is not. If you open it, you will get a square. All the things has been added in 144. Only this area has not been added. So this is nothing. It is half of the triangle area. The triangle area, which is half of the square area. 36 ka half, 18. Add 18 to get the answer. Easy. Come to the next one. Okay. So now in the next class or in the next session, I will take the questions from 2016 to 2018. This video I'm ending it here because otherwise it will be a longer video, more than 1 hour. Okay, it will be difficult to upload. So check my next video to do the remaining question. Obviously, there are lesser question in the next video, but if you do these 30 questions based on geometry, I think all the concepts will be revised. Okay, thank you. Check my next video.